Hello students, welcome back to a series of Chapter 5 videos, Chapter 5 on Standard Normal Distribution. We're going to go into Part G now, where it says what's the percentile for someone with an IQ of 118. So normal distribution and percentiles. Remember percentiles back from Chapter 2. We can now calculate specific percentiles for an observation in the population. So this is Part G. Percentile was someone with an IQ, that's not Q, IQ of 118. So let's draw this out to get a really good understanding of what we're looking at. There is our average right in the middle. Normal distribution has the standard deviation of 15 and an IQ of 118. 118 right there. So we want to know this percentile. Percentiles are given as the how much more that value is from the rest of the population. So percentile is basically everything to the left. So we want to know all of this area, and that is going to be their percentile. So we can start by doing this. Basically, once we draw it out, we understand that it's a three-step process. Step one is calculating the Z value for that IQ, or that IQ of 118. This gives us a Z value 1.20. Step two is to take that Z value and find an area. We look at the normal reference table. 1.2 is right there, 3849. So our area is 0.3849, and our answer, readily observable, that we add 0.5 to that area we got in step 3 or step 2. So this is 0.8849. So remember that the area we get in step 2 is always from the middle outwards. This area here is 3849. This area on the left side, all of it is 0.5. So that's why we are in that percentile. So basically this could be read as the 88th percentile. So someone who has an IQ of 118 would be in the 88th percentile. Let's go into Part H. Part 8H asks for the percentile for someone with an IQ of 92. So let's change this. IQ equals 92. So let's draw this out. There's a normal distribution. Average 100. Standard deviation is 15, and 92 is going to be on this side. There's x equals 92. Percentile is always read from looking at the far left. So this person with an IQ of 92 has an IQ greater than what percentage of the population? So basically, what is that percentile? So let's do that three-step process. Step 1, Z equals 92 minus 100. Divide by 15. Z value is going to be negative 0.53. Step 2 is to find that area that corresponds to the Z value of 0.53. We look at the normal distribution table. 0.5, 0.3, right there, there's 0.5. Up there's 0.3, so 2019. So the area we get is 0.2019. Remember the area, so this value here is always from the middle outwards. So this is 0.2019. We want this area in red. We want this area here. That's a big unknown. So step 3 is to find our answer. We're looking at one of the extreme ends of the distribution, so we're going to subtract 2019 from 0.5, and we get 0.2981. So this person here scoring an IQ of 92 would probably be in the, we just round that up to the 30th percentile. Has an IQ greater than 30% of the population, has an IQ less than 70% of the population as well. Let's erase this. Let's go into part I. IQ point for someone in the 90th percentile. Okay, so we want an IQ point. We don't know the X value. The IQ for someone in the 90th percentile. So question I, what is the IQ in the 90th percentile? Well, when in doubt, let's draw it out. So there is a normal distribution. We know that IQ is distributed with an average of 100 and a standard deviation of 15. The 90th percentile, we want to shade in 90% of this area, starting from the very far left. So we're going to shade in all of that area. This is 0.5. 50% of the area is on the left side. We want to draw up until we get to here, and this area here is 0.4. All of this area up into this magical point X, which would correspond to the 90th percentile. So this question is a backwards type question. We're going to do the three-step process backwards. So the starting point is, we know that the area is 0.4. That area 0.4 is going to give us a Z value, which in essence is going to, we can turn back to an X value using that formula. So let's look in the normal distribution. Instead of having a Z value and finding the area, we know the area. We know the area is 0.4. Now area, top left starts really small, bottom right gets bigger. So the areas increase as we go across and increase as we go down. So find the closest value to 0.4. 0.3997 at 1.28 is the closest value to 0.4. So this is a backwards question, so we're looking for the interior number first. We know that it is 0.4, which corresponds, this is the closest. Going one more above is not as close as this value of 0.3997. So it corresponds to a Z value of 1.28. So that area gives us a Z value of 1.28. We put this into our formula. 1.28 is Z equals X minus the average divided by 15. So if we carry out this calculation, I'll just show you how to do this. We're going to multiply the standard deviation on the left side. We're left with X minus 100. So the left side equals 19.2. X equals X minus 100. We're going to add 100 to both sides. So we get 119.2 equals X. This corresponds to, this means that a person with an IQ of 119.2 is in the 90th percentile of the population in terms of IQ. So let's go on to part J. Part J is very similar to part I. What's the IQ point for someone in the 23rd percentile? So let's go back here. Let's erase this. And now let's go here. J is basically being, what's the IQ point, which we don't know, for someone in the 23rd percentile. 23rd percentile. Let's draw this out. There is normal distribution, average 100, standard deviation 15. Someone in 23rd percentile is in the lower end of this distribution. So basically, maybe right there, gives us an X value and a Z value, which we don't know yet. That's what we're trying to calculate. So basically, 23rd percentile is everything in this red area equals 20.23 or 23%. When we find area, or when we find that Z value, Z normal distribution, always goes from the middle outwards. So we need this area in here. This area is going to be 0.27 because 0.5 minus 0.23 equals 0.27. 0.5 because everything on the left side, everything from here all the way down there is 0.5. We know the red area is 0.23, therefore the missing part is going to be the difference. 0.5 minus 0.23 is 0.27. So that gives us 0.27 is going to lead us to a Z value. Area is 0.27. Z will then equal, let's go over here, Z will equal 0.23 is the area. 0.23 is the area, gives us a Z value. Z value, where are we looking here? 0.23, 0.27, right in there. 0.74 is the closest Z value to an area 0.27. So the Z value is 0.74. It's on the left side, so it's negative. If you forget the negative, you're going to get an X value that is going to be greater than 100. So calculating that, finding that X value is negative 0.74 equals X, which we don't know, minus 100 divided by 15. So negative 0.74 times 15 equals X minus 100. This is negative 11.1 equals X minus 100. Add 100 to both sides, and we're going to get 88.9 equals X. So someone with an IQ of 88.9 or close to 89 is in the 23rd percentile. So a couple things to remember here is because we are on the left end of the distribution, the Z value is negative. You need to remember that negative Z value. If you forgot the negative and you keep that as a positive Z number, 0.74 positive, you're going to end up with an IQ of 111.1, which is going to be over here, which is clearly not representing a value of the 23rd percentile. So we'll continue with Chapter 5 in the next video.